Awesome guys, so I guess there's not too much more to factorizing polynomials than what we've actually seen before. That is, we grab a whole bunch of skills that we've previously learned and we put them all together in a nice neat little package. But I'm actually going to show you how you can go through and do this whole process in a much nicer and faster and easier way. That is how to synthetically divide polynomials, because this is actually going to remove the whole long division process, which is generally the area where people go wrong. Alright, so let's look at a little bit of an animation on how to do just this. Let's check it out.
So today we're going to have a look at how to synthetically divide polynomials, but before we do that, let's just have a quick little refresher on the process involved when long dividing polynomials. Now, if you recall back to the animation that I made in regards to long division of polynomials, we had this problem here, that is x cubed plus 3x squared minus 5x plus 7 divided by x minus 2. Now, we're not going to go through all of this again, but what I do want to refresh on is just the processes involved. That is, in order to be able to achieve this answer, we first of all divided, then we multiplied, then we subtracted, and then finally we dragged. And once again, we just repeated this process over and over again until we got an answer that looked like this. Now, as we know, this process is quite long as it involves a large number of steps. So what I'm going to show you today is how to get to the same answer, but we're going to use a different method, that is synthetic division. Now, it's important that you take note of the quotient and the remainder at this point, because obviously we want to get to the same answer, but obviously using different methods. So let's just say we've got this problem here where you've got x cubed plus 3x squared minus 5x plus 7 divided by x minus 2. Now, it's more likely to be written out in this form here. Now, the very first step when synthetically dividing polynomials is to draw out what I call the box, that is this. And inside the bottom left hand corner of the box we put an addition sign, and outside the bottom left hand corner of the box we put a multiplication sign. The second step is to change the sign of the divisor and write this outside the box. Therefore, in this example we get the negative 2, we turn it into a positive 2, and we write this up the top left hand corner outside the box. Now, the third step is to write the coefficients of the numerator inside the box along with the 0 underneath the first coefficient. That is, we get the numbers in red and we write them down here. Then what we need to do is write a 0 right underneath the first coefficient, in this case being 1. Now, step 4 is to add the first coefficient with the 0, and you write your answer directly below underneath the box. Therefore, in this case, we've got 1 plus 0 is equal to 1, and we write our answer directly below. And step 5 is to multiply whatever's outside the box, and you write your answer in the next available space that can be found inside the box. Therefore, in this case, you'd multiply 2 by 1, giving us 2, and we write this just inside the box here, as you can see. And finally, step 6 is to repeat steps 4 and 5 until you've fully completed dividing the polynomial. Therefore, we go through and do 3 plus 2 is equal to 5, remembering to write our answer directly below. 2 multiplied by 5 is 10, and once again we write our answer in the first available space after the 2. Negative 5 plus 10 is positive 5, remembering to write our answer directly below. 2 multiplied by 5 is positive 10, writing our answer in the last available space inside the box. And 7 plus 10 is 17, remembering to write our answer once again directly below. Now let's have a look at the numbers outside the box for a second, shall we? These are 1, 5, 5 and 17. Now if you have a close look, 1 is the same as the coefficient of the x squared, 5 is the same as the coefficient for the x, 5 is also the same as the constant, and 17 is the same as our remainder. Now these numbers are extremely important to us when we divide synthetically because they're actually going to give us the coefficients for each of our terms in the quotient. That is, the last term will always be the remainder, the second last term will always be the constant, the third last term will always be the coefficient of the x, the fourth last term will always be the coefficient of the x squared, and as you can see, this pattern will continue with each power of x increasing for every number that you have below the line.